Alright, in the section 4.4 we discuss about how do we solve or how do we find the equation of motion of the object that is hang on the bottom of the spring. So in the first case we said no damping and no external force, right? In the second case we consider damping with no external force. But there are two more cases for the spring mass system, that is no damping with external force and then damping with external force. If there is external force, the second order differential equation will have a non-zero term on the right hand side, right, which we call non-homogeneous equation. So to consider those two cases, or to solve or to find the equation of the motion in those two cases, damping and no damping with the external force, first of all we need to know how to solve a second order differential equation that is non-homogeneous. Okay, so let us recall a little bit. So if Ly, the operator L, equals to y double prime plus pty prime plus qty, then the equation Ly equals to gt is called a non-homogeneous equation, where p, q and g are continuous function on the open interval y. Okay, so do you remember how do we write the homogeneous equation in terms of Ly? Then the homogeneous form in terms of L will be L and then y equals to 0. If the right hand side is 0, it is homogeneous. If the right hand side is not 0, then it is non-homogeneous. So on this section we are trying to solve a non-homogeneous equation. Okay, there are two theorems at the beginning. So if y1 and y2, the big y1 and y2 are the two solutions of non-homogeneous equation Ly equals to gt, then the difference y1 minus y2 is also a solution of the corresponding homogeneous equation Ly equals to 0. What does it say? If there are two solutions of this non-homogeneous system, then their difference will be the solution of the homogeneous system. That's what it says. It can be easily proved, because if y1 is the solution, then you will get Ly1 equals to gt, right? And if y2 is the solution, then you can get Ly2 equals to gt. Now if you subtract, then gt and gt will cancel out, so you will get Ly1 minus y2 will be 0, right? That's what you get Ly equals to 0 will be the equation for the difference. And furthermore, if y1 and y2 are the fundamental set of solution of the homogeneous system, then the y1 minus y2, the difference can be written as the linear combination of the y1 and y2. Okay, so there is another theorem that says the general solution of the non-homogeneous equation Ly equals to 0. How does the general solution of the non-homogeneous equation look like? Is this. So you have yt equals to c1 y1 plus c2 y2 plus yt. Okay, where these are the lowercase y1 and y2, and this is the uppercase. So where y1 comma y2 are the fundamental set of solution of the homogeneous system, and uppercase yt is some specific solution. What is that? We will do that, some examples here, of the non-homogeneous equation. Now, what are the steps to solve a non-homogeneous equation? Find the general solution of the homogeneous part first. Okay, we call complementary solution. The method we used so far, all the method we used so far is we use the eigenvalue method basically, right, to solve the homogeneous part, and find some solution yt of the non-homogeneous part. We call the particular solution. For the non-homogeneous equation, we find one solution, at least one solution, that is called the particular solution. And the method to find out the particular solution, there are different methods. On this section we will discuss about method of undetermined coefficient. Okay, you find the sum of those two solutions. That's how you find out the general solution of the non-homogeneous equation. So let's discuss about the method of undetermined coefficient. So this method may not be useful for all types of problem. This is more useful if the GT, that means the right hand side function, is a polynomial function or exponential function or sine function or cosine function or sum or difference or product of those functions. Then this method makes the problem easier. Okay, for different types of problem, we use different methods here. So let us discuss how do we solve this problem. Okay, so our goal is, I want to find out the particular solution. To find out the complementary solution, you just set that equals to 0 and use the eigenvalue method. But we are talking about the particular solution here. So we want to talk about the particular solution of this equation. So we want to find, we need to find yt such that y double prime minus 4y prime minus 12y is equal to, let's say, is equal to 3e to the 5t. So that's what you are looking for. You are looking for yt. When you plug in on this on the left side, you must get the right hand side, right? That's what the solution means here. So here, since the right hand side is in the form of like a number times e to the 5t, I expect the solution like e to the 5t form, because when you find the second derivative of e to the 5t, you will get some number times e to the 5t, first derivative e to the 5t, right? So since we need the e to the 5t on the right hand side, so we assume is let that yt equals to a e to the 5t. Okay, that's what you do. And then we will try to find out y double prime, y prime, and then plug it in here, and then we'll try to solve for a. Okay, so then what is y double prime? Then basically this is uppercase y double prime. So y double prime will be how much? It will be the first prime will be 5a e to the 5t, second prime will be 25a, right? So 25 a e to the 5t, and then y prime we will plug in that too. Y prime is also 5a e to the 5t. That's what you do. Now what you do is you plug in these values into the given equation. So what do you get? Then you will get 25a e to the 5t minus 5 times 4 times a times e to the 5t, and then minus 12, and then a e to the 5t equals to 3 e to the 5t. Did you see what I did? I just plug in the value of y double prime and then y prime and then y there, right? So if you simplify, what you get? A e to the 5t is common to all of them, right? So you get a e to the 5t. So what is left is 25 minus 20 minus 12, right, equals to 3 e to the 5t. Did you see that? So what you do is, how much is that? This implies 25 minus 20 is 5 minus, so negative 7a, right? Negative 7a e to the 5t equals to 3 e to the 5t. So if you compare these two, e to the 5t cancel out, so you get a equals to negative 3/7, right? So you get, this will implies negative 7a equals to 3. So a equals to basically you get negative 3/7. Hence the solution is yt equals to negative 3/7 e to the 5t. That is the solution. So what is the basic idea is, what you do is, depending on the right hand side, you assume some sort of function as a solution and then try to find out the constant, right? Here, since the right hand side is 3e to the 5t, what I did is I assumed that the solution is yt equals a e to the 5t, because I know that any derivative of this function will have e to the 5t. So I would expect that on the right hand side of, or if you plug in those values here on the left hand side, then you expect that e to the 5t, any derivative will give you that e to the 5t on the result. That's how I assume that. Okay, this one. So which is the very important step here. Let us do another example. We have find the particular solution of y double prime minus 4y prime minus 12y equals to sine 2t. Basically the left hand side is same, right? Only the right hand side, instead of 3e to the 5t, you have sine twice t, 2t, right? Okay, on this example, what we do is I would assume that the solution of this is some sort of like function of sine twice t. Let yt equals to a and then sine twice t, and then I'll find out the derivative, first derivative, second derivative, and then plug it into there, right? So what will be the first derivative of this? So y prime is basically 2a cosine twice t, right? What is the second derivative? It will be y double prime is equals to negative 4a sine twice t. That's what you get, right? If you plug it into the equation and then compare that, what you get is basically negative 4a. So you use in the equation, the given equation. If you plug in that, you will get negative 4a sine twice t, that is the second derivative, and then minus 4y prime is 8a cosine twice t, right? That's what you get, and then minus 12a and then sine twice t equals to sine twice t. You see that? So we will get so what do you get here? You get let's say negative 4a sine twice t and negative 12a sine twice t will be negative 16a sine twice t minus 8a cosine twice t equals to sine twice t. You see that? And then what do you get? So what do you how do you solve this for a? Is you compare the left side and the right side, right? So if you do that, then what you get is negative 16a equals to 1, because the coefficient of sine twice t is negative 16a and the coefficient of sine twice t is 1, right? So this implies a equals to negative 1 over 16, but there is no cosine twice t on the right hand side, right? So what do you get? There is no cosine twice t on the right hand side, so what you get is you get negative 8a equals to 0. This implies a equals to 0. So this looks like it is look at this value and this value. It says a equals to 0 or a equals to negative 1 over 16. That is not right, because we have only one a there, right? So you get only one value of a, but there are two different values of a. So the function we took is not right. Why is that? What is the reason why? Because I was assuming the straightforward way that since there is sine twice t on the right hand side, maybe a sine twice t will be the solution, but I got different values of a there, right? So what you do here is, the reason is because the first derivative, there is a first derivative term, and the first derivative here is cosine twice t. So maybe what we should have done is let y of t equals to a sine twice t plus b cosine twice t. if you do that, then you will get something to compare there, right, on the left side and right side, so that you can find out the value of a and b. So if you do this, if you find out yt, and then you find out y prime of t, you find out y double prime of t, and plot here, okay, what you get is you will get two equations. So the steps are find y double prime and y prime, and use it in given equation. We get two equations. We will get the values like negative 8a minus 16b equals to 0, and we will get another equation negative 16a and then plus 8b equals to 0 as well. And if you solve these, you will get a equals to negative 1 over 20, and b is 1 over 40. b equals to 1 over 40. That's what you get. So again, what you do is yt equals to consider both sine and cosine. The reason is because y prime got cosine. So in this case, just a equals sine twice t, like we did here. Because on this problem, all the derivative has e to the 5t, right? But here, some of the derivative are cosine t, some of the derivative are sine t. That's why we need to consider yt equals to a sine twice t plus b cosine twice t, that way. Okay, so if you do that, then you will get and find the first derivative and second derivative, and then equate the left side and the right side, set them equal, then you will get two equations. And if you solve them, you will get a equals negative 1 over 20, b equals to 1 over 40. I left this work for you guys, okay, because this is just a straightforward thing. So what is the final answer then? The final answer is yt equals to negative 1 over 20 sine twice t, right? And then let me write parenthesis here, and then plus 1 over 40 cosine twice t. That is the final answer for this problem. So the idea basically is, you see that what should we assume for the answer, what form the answer will take, right? If there is exponential function, you do a and then exponential function. If there are two exponential functions, then you will have to do like, suppose if there is like e to the 5t plus e to the 3t, then you would do a e to the 5t plus b e to the 3t, because they are two different things, right? Here there is just sine t. I don't do when I did a sine twice t, it didn't work because some of the derivative give you cosine twice t. That's why I have to assume a sine twice t plus b cosine twice t. So we will see some more example in the next slide.